I built these rockets, and they're hobby rockets, so they have these special hobby rocket motors that you can light with electricity.
Uh-huh.
And my idea is to make a fully modular system where you can stick so you have a body and then you have some fins, so you can just add the fins on, and then you just tape it, and then you can just launch this rocket as it is, and you don't, and you can change the fins out for something like this fin. So you just put this in.
Okay, so this is interesting because normally when we build rockets, right, then the fin is part of the body. So you put the fin here, right? But you're doing it so that you can switch in and out different fins. So then the fire coming out from the motor is very hot. So what is it that you're doing to prevent it from burning?
So we have to fill the inside with aluminum foil. So then when it hits there, it doesn't char the body.
Yeah.
It just heats up the aluminum foil.
Okay. So normally rockets, in order for them to be stable, right? So that it flies up, it doesn't do this, right? Then the center of gravity and the center of pressure, they have to be in some kind of relationship with each other, right? What is it?
The center of pressure has to be before, towards the bottom.
Towards the bottom. What is the center of pressure?
Center of pressure is when the air hits it. How does it
act on the rocket body?
Yeah.
How the air pushes on the rocket body.
Yeah.
Okay. And then the center of gravity is
where the weight is.
The weight, right? You balance it, right?
Yeah.
On your finger or whatever. So when the center of pressure is forward, so it's pretty much like an arrow kind of thing. So the weight has to be forward.
Yeah.
So if it flies and it turns a little bit, and the center of pressure is backwards, then what it would do? So let's say it flies like this, and it turns like this, and it starts flying up like this, and the center of pressure is backward in the back, then it will do what?
So then the air will push it down.
Oh, push it down so that it turns this way.
Yeah.
So it realigns itself.
Yeah.
Okay, so what you're doing here is interesting because the side effect is the center of gravity moves forward, make it more stable. Huh?
Yeah.
Make it more stable. And you can switch different, you can have different, this one, tell me about this one.
Oh yeah. So
this is a different one that you made, right?
This one is a special thing where this one it has these it has tubes right here. So 4 tubes, and we're gonna put 4 motors in here. So then we can actually
so have 5 motors total.
Yeah, 5 motors total. And what we're gonna do, let me just put it in. What we're gonna do is we're gonna light all 5 of these motors at the same time, and it's gonna launch up. And then these 4 motors are gonna burn out quicker than the motor in here. So then it's just gonna fall off, and then this thing will keep flying up.
So there's a thing at the end towards when it burns out, it will fire in this direction, drops off this first stage.
Yeah.
So this is a multi-stage rocket.
Yeah, multi-stage. But it lights all the engines at the same time.
Right. Okay. So this is different from other multi-stage where this first stage has to burn completely and then light up the second stage. But your thing is different. But this is all based upon the modular design. How do you make sure that this thing? What kind of motor do you have here that burns out faster than that?
Okay. So right now our plan is to have we don't. Let's see.
You haven't decided yet?
Yeah, I haven't decided yet.
Okay, but then this is like either a D motor or a C something, and then this seems to be.
It's a C11.
Oh, C11, C11-7. So this will burn. I don't know how many seconds. Did you check?
I think 0.8 seconds.
0.8 seconds, and then we'll have a delay of 7 seconds before it fires.
Yeah, but our plan is not to use the C11. We're going to have a different motor inside there.
Okay, so you might need to have an adapter and use a smaller motor. Okay, so tell me about this one. This is interesting.
Okay.
This one, I was concerned because if you're looking from the side, it's very small, right? It's as if you have, like normally when you have things like this, but this one, it's like a box. It's much stronger, right? This one can break easily. This one is much stronger, but then if you look from the side, it's as if you have two small fins on each side. But you're saying that it's not.
Yeah, because when the wind blows down, it doesn't matter what the side angle is. The side angle only matters if the rocket is flying this way, which it shouldn't. So if it's flying this way, like this, and then it is flying up,
straight up,
then
okay.
it tilts slightly.
It tilts slightly.
Then it'll have the same area as if you take this and you tilt slightly.
Because you have this area, and then you also have
this area on the
this
other side,
area,
and
then
four.
these four also have slight areas.
Yeah.
So then they will act as if it's a big thing. Okay, very interesting. All right, great. Thank you, Anthony. I look forward to seeing this thing fly. We're gonna make you're gonna make a video for this thing when this thing fly. Okay? Yes.
Okay.